Hello everyone, welcome to the third episode, live episode from Case Done by AI. My name is Pisek, or you can call me Benz as well. Today I have 4 exciting topics that I would like to share with you today. It's about the world of AI for sure. So let's get started. So what we will be talking about are these. Gemma, an open source model from Google, and we will talk about the newest model from Mistral AI team. And then I would like to share some technical models that will be coming in the future, very exciting and promising. And the last one is going to be about the business success case from Klarna. So a few weeks ago, Google has released a model called Gemma. It's from their DeepMind team. And from what the document said, it's based on the architecture and the technology that is similar to the Gemini model that they have released before. Now, this model are available in 2 sizes, 2 billion parameters and 7 billion parameters. And both of these sizes have 2 versions, the pre-trained version and the instruction-tuned version. Now, according to its website, these models are supposed to be best in class performing compared to the model of similar size and also open models as well. And what is exciting, and I want to test it out, is that it should be able to run on a laptop. In terms of performance, how is it compared to all other open source models? In this chart given by Google's white paper, it's comparing Gemma with models, open models like Llama 2 and Mistral model, like 7 billion parameters, across 4 domains of task. The first one is question answering. The second one is reasoning, the third one is about math and science, and the last one is coding. So Gemma is in the green boxes here, while the other models are in other colors, so like so. And the y-axis is actually the score for the performance. So it seems like with the Gemma 7 billion parameters, this model can compete with Llama 2 and Mistral 7 billion parameters, especially it's winning in math and science and coding. So this is very exciting. If it's open source and you are needing the model to do custom tuning to fit your business in the tasks that are like related to question answering, reasoning, or even solving some maths, probably basic maths, and also coding. So this Gemma model could be the one that you need to borrow and fine-tune it for your applications. So the model is now available on Hugging Face and Kaggle. Here, this is Hugging Face website. You can search in the box for Google's model, and especially you can specify that it's a Gemma model that you are looking into. So let's actually go and use it. So I am in my web browser now. I'm actually in Kaggle website. This is the Gemma model from Google, and you can see that people have started using it. These are some notebooks that you can take a look. So for example, one of them, I actually clicked this one, Gemma meets LangChain, summarize Kaggle writes up. So this is what people have tried before. For those of you who are adept to programming, you can actually take a look at how this notebook is all about. This is like import the model, run Gemma directly. Like that, you give it a maximum length. This is like 256 tokens that the Gemma model will generate. It takes about 12 seconds here. LangChain is a library that helps structuring and providing tools to use the LLM. And this is something that I will be talking specifically in the future. this is Hugging Face, a website that I was talking about. You can Google, not Google, you can search for Google models here, and you will find Gemma and other models like this, like a flat and T5 models. So as I mentioned, Gemma has two versions, right? The 7 billion parameters and the 2 billion parameters, but also two varieties of training. The IT, this one means instruction fine tuning. So you are supposed to use these models if you are using it for conversational purposes like a chatbot. The base model or the pre-trained models, actually it's recommended for you not to use it directly. You need to take the model and fine-tune it later. For example, using like supervised fine-tuning or instruction fine-tuning. What I'm interested here is, can I just use it right now? It's supposed to be open, right? Open source, right? So what it turns out is that I can. But if this is the first time that you are doing this, you need to sign up, create an account with Hugging Face, come in here to this model and request for access. I have done this myself, so this I have got my access to this model. But if this is your first time, you need to do this step. It's easy. You just click a button. You're supposed to read some terms and conditions first too, and then click the button. But after that, now you have the access too. All right, so what is this thing? This is a page called the model card. It's supposed to contain all the information that you need to know before you use the model in your application. So, okay, I'm going to read through this. This model responds to the 2 billion instruct version of the Gemma model, as I mentioned. Again, it's signified here with the int at the end of the model name, model version. Also, Gemma, one of the highlights that Google advertised when they released Gemma model is their responsible generative AI toolkit. I guess this is a work in progress, because a few weeks ago, as you probably have known, some of you might have known this, their text-to-image generation model has created some undesirable images that inaccurately depicting historical events. I don't want to go into the detail like this, but this is in the scope of making AIs that are responsible in a sense that it's ethical. It reduced the bias, like racial, sexist bias from the model. And seems like Google is fixing what it had done, but I'm sure that in the end, Google will be able to achieve that. Let's continue. These are the terms of use. You can read it here. Now, this is the description. So as I mentioned earlier, this is based on the Gemini technology. It's a text-to-text, so pretty much a large language model. It cannot create images right off the bat. In terms of the usage, this is in Python, I think. Not I think, I'm sure this is in Python. Now, in this model card, it provides you with instructions how to use the model in CPU setup or GPU setup as well. This one is about using the model in full precision. We will be talking a little bit about this in the next section. But now you can run these models in full precision or quantized bits, quantized models, so that you reduce the size of the RAM or the memory that you need. So yeah, you can follow these instructions in order to try to use the models. So what I will be doing here is I would like to run the model on a CPU. The reason I'm doing this is that I want to show you how to use Colab. Colab is a tool that allows you to run Jupyter Notebook on Google's infrastructure, and it turns out to be free most of the time. So the way it works is that you go to Google Colab. It was supposed to be so the file will be saved in your Google Drive, but you can search for Google Colab. You can sign up and start using the notebook again. So Colab is a hosted Jupyter Notebook service that will be run on Google's infrastructure, and the file or the notebook itself will be saved to your Google Drive. So there are resources that you can here. You can change the runtime type. You can choose to run on CPU, GPU, or even TPU, right? But there might be costs associated with running GPU and TPU. So I would like to stick with the CPU for now because it's free. So I can choose that, okay, I'm running CPU, I will be using Python 3 rather than R, and then I'll save it. So then I need to connect to a new runtime. So what is this doing is actually going to communicate with the Google infrastructure, asking for compute resources, for example, the memory like RAM, and the GPU, the disk like this. So you can see that these are the resources that I get from a free version. But if you need more memory and disk space, you can upgrade to Colab Pro. It will be some cost for sure. But what I want to try is whether I can just use this library for free, right? Using GPU and Colabs. It will take some time. So what it's doing is I run this cell. Now Google Colab has this. Oh, I need this. Title: Gemma CPU doesn't have access to secret name. Grant access. I do need to grant access. Okay, what's happening behind the scene is I'm downloading this model from Hugging Face, and in order to do that, I might need some tokens or access tokens. Actually link my application on Colab to my profile on Hugging Face, and this is done by coming here to the setting in your Hugging Face and create some tokens or message or key, and then provide it to Google Colab to do so like this. This is my Hugging Face token. I provide it here so it can now Colab program can use this token, verify my identity to Hugging Face, and download the model. You see that it's been a while. It's not done yet. So what it's doing is that it's downloading tokenizer, one of the components that we need to process human language into the numeric language that the model understands. I will have a course about this for sure, so that we provide a basic background to people who want to know it in detail, but not going to be doing that at the moment. So now it has download and initialize the tokenizer. In this one is downloading the model. So this model is almost like 5 gigabytes already, and you can see that now it's used up my system RAMs, the almost 12 gigabytes. Luckily it's not full yet, so I can still run this. So I want to ask the model, what is the capital of Thailand? This is a human language, right? This is called input text. Input text will be given to the tokenizer, which is going to tokenize this sentence. What I want to show you here is this is the numeric representation or the token representation of a human language. What is the capital of Thailand? We will feed this to the model. The model is this Gemma 2 billion parameter fine-tuned in the instruction fine-tuning manner. And okay, maximum length, I want to change it to 256, as we saw in the Kaggle example previously. Alright, so I am giving this numeric representation, or the token representation of my human language text to the model, and this will cause the model to generate the response. This will take a while because I'm running this on GPU and there are so many computations happening for the model. The model is providing words in sequence, right? So large language model is what? Is the model that predicts one word at a time, given the context that's come before. So this is happening. It's like predicting words by words. So, and also because I'm computing it on a CPU, it will need some time. Let's see. In this Kaggle example, it takes about 12 seconds to finish computation. It's coming up, guys. In my previous videos, we saw that when I was using Gemini or ChatGPT, the response time was about a few seconds, like 3 seconds or 4 seconds, much faster than this. This is probably because, not probably, most likely because they have fast infrastructure for computation. Oh, okay, it's done. The output is computed. What does it look like? Well, the output from the model itself is numerically gibberish for now. What we need to do is we need to use the tokenizer to convert the numeric language that the model understands back to our human language. Here comes. This is the output. The output seems to repeat my questions, but it has something appended to it. It's the answer from the Gemma model. Gemma says, the capital of China is Bangkok. It is the largest city in the country, and it is, and also the political, economic, and cultural center of Thailand. I think this is bang on. Pretty good. So I think with this example, you can actually have your hand on Gemma 2 billion parameter models and start using it. You don't need to pay ChatGPT for this service anymore. I think you can try using it yourself. One of the drawbacks of using it this way is it's very slow. But if you wanted to use GPU, you can buy more credits to use GPU on Colab as well. So I think this works, except that it is quite slow. And I doubt that if I load the 7 billion parameter model, I doubt that it will work at all. It's going to be really, really big. Actually, it's worth a try, right? So what I'm going to do now is I am going to locate this file on my drive, duplicate it. Here, I'm going to make a copy of it, and I should have renamed it first. All right, I'm going to close it. I am going to rename it to 7B on GPU. I'm 99% sure that is going to blow up if I load the 7 billion parameter model, but I'm trying it anyway. So we're not using this anymore, so I'm going to kill this session by disconnect and delete runtime. For those of you who are not familiar with Jupyter Notebook, once you kill your runtime, your results is there. You can actually save this and still see the results there. This is cool because I use this to present to my boss as well, while I'm not actually running anything. I just show the result. All right, so we are back to the 7 billion parameter that we are experimenting, that whether it's going to be loaded at all. So what I need to do is I need to connect to the Google's infrastructure, and once I connect, I will try to load this thing. 99% sure that it's going to blow up. It could take some time. So let's go back to the slide about Gemma. So yeah, as you have seen here, Gemma is an open source model. It's quite capable, 2 billion parameters. It should be able to provide you answers for general purpose knowledge. Not sure about advanced capability like reasoning, like math reasoning, but the 7 billion parameter counterpart should be able to handle that. Oh, again, my mistake. I need to grant the access here. So the tokenizer, so back to the 7 billion parameter that we are trying to load it up. Okay. Yeah, this is a problem. I'm not sure if it's going to be a problem or not. Seems like the tokenizers are loaded successfully. It's very small, so it should be fine. The model itself has 4 partitions. Each is about 5 gigabytes. I guess maximum of 20 gigabytes for the whole model. Not sure. Let's wait for a bit. But while we're waiting, we can talk about Mistral Large. Mistral AI has recently announced its largest and most capable model. They call themselves flagship model. It was like last week or something like that. Now, this model is not free compared to the models from Mistral that have made its reputation, like Mistral, mixture of expert 7x 8b parameter or something like that. This one I think it's trying to compete with big names like GPT from OpenAI and Google. This chart provided by Mistral's AI itself, it's comparing its Mistral large model to API callable large language models, mostly closed sourced model like GPT-4. And from the score on the y-axis here, it seems like it's coming the second in the world. The team also quoted that it can be used for complex multilingual reasoning tasks, including text understanding. This is pretty standard, but transformation and code generation, I think these will be quite useful. Gemini Pro is right here, but I'm not sure if they compared it with like Gemini Ultra or in the advanced version or not. So Mistral Large is supposed to be good at 6 languages: English, French, Spanish, German, Italian. Oh, sorry, it's 5 languages. But I guess it can handle other languages as well, but might not be equally well. The context window is now about 32,000 tokens. So longer context length that the model will understand. You think you can put in maybe like 100 pages of PDF into the context window and it will still understand. It's claimed to have precise instruction following. This is pretty standard if you compare it to like ChatGPT or Gemini servers. Nabono is now available on Azure, the Microsoft, because it's now partnership with Microsoft. This model can be called via the API. But I heard that it's going to be available in Mistral's itself Large Chat application as well. So to me, it's like it's competing head-on with OpenAI to provide chat services for the general public. But what I'm more interested in here is its capability to do advanced functions like RAG. RAG stands for Retrieval Augmented Generation. It's a technique that I will cover extensively in the next few episodes, but essentially it's a way to insert new information for the model to answer based on that given information. So it reduces hallucination, it it's a way to 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 give the new information to the model without training it, so reducing some computation cost. And for some reason, it's advertised that now this Mistral Large can output in a JSON format, so that the developers can have a better life at working with this model. So okay, that's a good feature to have, I guess. But now Mistral is, in my opinion, entering a money-making phase. Previously, it's more like kind of like exotic, not exotic, eccentrically interesting, very hippie and funky way of introducing large language model to the world. But now it's trying to make money. I think it's kind of makes sense. Okay, how it's doing is that their previous models like the Mistral 7 billion parameters and Mistral mixture of expert eight experts of 7 billion parameters model. These are still available on Hacking Face, so it's still open source. But this is from website. So if you are using this model right away from it from Mistral's AI API, you need to spend this much. I think this is just infrastructure cost. But if you want to use the model yourself for free, it's still available on Hacking Face. Now, the latest models are the Mistral Large and the Mistral Small and the Mistral Medium, but they haven't talked about Mistral Medium that much. Now, the small and the large are not free anymore. You need to call to you will need to access the model via an API call, and there is cost associated with it. For the input is for the large model is very expensive. It's like $8 for 1 million tokens for the input itself, but when it's generate output for you, it's 3 times more expensive. It's expensive. I think I've heard that it's a little bit cheaper than OpenAI's GPT-4 service, but still kind of expensive territory compared to other models in the market. All right, this is the end for the Mistral's update. What I'm curious now is Gemma, right? We are loading Gemma 7 billion parameters in the background, and it seems like it's not bad actually. Okay, I think you can actually use the 7 billion parameters Gemma modeled in Colab. It will consume disk space a lot. But yeah, luckily it's still running. So, actually it has crashed, I guess. Your session crashed after using all variables RAM. So yeah, correction. I don't think you can use Gemma 7 billion's parameter in Colabs because you don't have enough RAM to run it. So this cell has died. Well, I'm stubborn. I am going to run this again in the background, and then we'll come back to see how it goes. All right, march on to the next exciting topic. At least for me, it's a technical topic, so bear with me. After this topic of the BitNet, we'll be talking about business case, a successful case from a well-known company. So bear with me for maybe 5 to 10 minutes, I guess. All right. In the past week, I've heard something called a BitNet, and when I look at it, it has interesting promises. So with this new large language model, it will need lower memory, it will consume lower energy, and as a result, and maybe like related other features, it will compute faster. So this plot is from the paper that is about the BitNet. So it's comparing the BitNet, which is represented in the orange line and the orange data, as compared to the Llama models. in full precision. I will talk about the full precision in the next slide. But now this BitNet model is compared to the traditional llama-based transformer. In this plot, it shows on the x-axis is the model size, like how big the model is, like 7 billion parameters, 3 billion parameters, and so on. On the y-axis, now this plot is latency, how long it takes for the model to give you an answer. You can see that the latency for the BitNet is significantly shorter than the Llama full model ones, on the average of about 3x to 4x. Actually, so from the trend I see here, the larger the model size, the more you save in terms of latency, the faster what the model is. In terms of the memory, again, this is obvious. For the BitNet, the larger the model, it seems like the BitNet model can save more and more memory for the model, right? In terms of energy consumption, it has reached up to like 30x and 40x energy needed. And this is very important for companies if you are walking down the path of sustainability, right? So you can see that this BitNet has high promises, and the potentials are, to me at least, it's huge. When the model can run with lower memory and lower energy, it's suitable for running the model on edge devices like your mobile phone or IoT computer at the edge, far away from the data center, something like this. If the model can run, if the computer on the mobile phones can run the BitNet large language model that has the capability of, let's say, GPT-4 as we have now, what kind of application that it will unlock is huge, right? In terms of the company, if you want to custom made your model by fine-tuning it, it's more affordable as well. The model is no longer really big. You might be able to train it on very affordable GPU or even a CPU, right? And as a human race, towards sustainability and reduce energy consumption is the goal. And yeah, this is why I'm very excited about this model, and I hope this is going to be made in production and adopted globally. All right, let's dig a little bit deeper. So hang on tight. All right, so large language models are made of neural networks called transformer, and inside a transformer is a lot of numbers, usually floats, and these floats need to be undergone math operations, mostly multiplication and addition. This is time consuming and energy consuming as well. But what are the floats? Floats are number with decimal points. An example is like 1.2345678 This is an example of a float. The number 1, if you represent it as 1.0000, is now a float rather than an integer. So inside a transformer, it has a lot of floats, and each value, like each float value, needs 16 bits to represent. 16 bits. Remember, computers are made of bits, right? 0 and 1. So one floating number needs 16 1 and 0 bits to represent. Therefore, for a 1 billion parameters large language model, it will need 16 billion bits, or roughly 4 gigabytes of memory to hold it. So by the way, parameters of the large language model are usually called weights. So we might be interchangeably use the terms parameters and weights interchangeably. So transformer has floats. Floats need bits to carry, and each float in full precision, it takes 16 bits. The consequence of the floating precision is that the more floating precision you hold, the more memory it takes, and the slower the computation of multiplication and addition it takes. And what you are seeing on the right hand side is the decoding stack of the transformer of the large language model. And it's everywhere, like in linear path, in addition path, feed forward path, multi-head attention. You have floats everywhere and multiplication and addition everywhere. This is where the memory is taken, energy is taken, time is taken there. The community, research community and industry community as a whole knows this capability, know this limitation, or knows that this is a problem we need to solve. One of the ways that we are trying to do is to solve this is called quantization. Essentially means reducing the precision points that we need to represent the model and compute the model. So FP16 is a full precision. This is the standard way, or the original way of how the large language model is represented. It needs 16 bits to represent one float number. Popular quantizations dropped the precision from 16 bits to 8 bits or 4 bits. So this is what is popular or standard procedure right now. The BitNet is very extreme. It reduces the bit to just 1 bit. You can't go below that. 0 bits means nothing. You don't do anything at all. You just walk away. There's no information. So this is the most extreme quantization that the community is trying to do to solve this problem. So what is typically happening in quantization workflow is that there are 2 types. The first type is like this. People will train the model, train the large language model at full precision, FP16. And once you get the model, you quantize it. You chop out precisionness. And so for example, you quantize it to int 8 or int 4. What happens is that the model will have degraded performance. This is known in the industry and the research community right now. The second approach is a little bit difficult, a little bit more difficult. It involves a training that is adapt to quantization. So the quantization is now embedded in the training process. It's called quantization aware training. It helps with avoiding degraded performance, but there are challenges like the conversion of the training is not easy, and the scaling, like how when the model grows in parameter sizes, what about its capability? What about its accuracy? The scaling law is unclear how it's going right now. This is from, I forgot to mention, all of the information that I am telling you now is from these 2 papers. They are researchers from Microsoft, and you can actually go to, you can Google this BitNet paper, and you will arrive at these 2 papers. It's a cool read. It's not that difficult at all. All right. So from the papers, this is what is described. My summarization here. So take a look at this plot. The x-axis is the bits, the number of the bits. So usually people start here, right? Training at full precision, 16-bit. And during usage or inference time, they try to quantize it. So they chop it. They chop the number of precisions. This is the purple line here. And accordingly, you see the performance, the accuracy of that modeled the quantized or chopped precision dropped. This is the degradation in performance that I mentioned. On the other hand, the BitNet started being trained at 1 bit, and that's it. You don't need to quantize it. You don't need to quantize it anymore. It's over there, and seems like it can uphold the accuracy. It is actually better than starting training at full precision and quantize it later. So this is the premise of this paper. It shows that you can get a good large language model by starting with a 1-bit net. So this is one of the second paper mentioned. It is a variation of the BitNet. So one number in the transformer can represent 3 values: -1, 0, and 1. What results here is that now the operation of multiplication is no longer needed. You avoid this at all, so it's faster and very, very energy efficient because you don't need to do multiplication at all. This is significant, and if this is actually true and it can be productionized, you will get to see a new hardware. GPU is optimized for multiplication and addition, but if you don't need to have multiplication at all, there will be a new hardware that is suitable for this type of model. Okay, now one of the cool things that the others of the paper have done is that they proposed this model that is compatible with current libraries or current models. Here, I'm comparing the BitNet architecture and the traditional full precision transformer. They are essentially the same, except minor modifications in the code. So this is the full precision transformer. You are seeing different modules like the attention head module and the feed-forward module. So in these modules, you have linear operations. Linear operations just means that you need to multiply metrics and matrices, some addition, and then some, that's it. And that's a linear multiplication. So this is a typical way that neural networks will have. Now, the proposed BitNet replaces the linear multiplication with a bitlinear, in which this is the bitlinear module, in which weights or parameters are just 1, 0, and sometimes -1. And this removes multiplication from the picture. And the way the researcher has done is that they actually replace the linear operation in the transformer with the bitlinear transformer, and that's it. And they also have provided some implementation examples in PyTorch and made it available on GitHub, so you can actually go there on GitHub, pull the code, and try to implement the BitNet yourself. So what about the performance, right? Well, the architecture is nice, the idea is nice, but if it can't compete with typical large language model, there is no point. In the paper as well, they compare the BitNet itself to the Llama full precision model with different sizes, parameter sizes. So if the model size, say 700 million parameters, if the model size are not big, the performance right here, the performance of the BitNet is lower than the full precision for sure, right? But what is interesting is that once you keep increasing the model size, let's say from 700 millions parameter to 1.3 billion parameter, or even larger, like 3 billion parameter, you can see that the performance gap dropped. Essentially, now if you compare the Llama index Llama 3 billions parameter to BitNet almost 4 billions parameter, you can see that the BitNet itself, the BitNet 4 billions parameter actually win over the Llama 3 billions. But the cost of using this model, like the memory and the latency, actually are still much lower. You see, like 3x lower for memory and 2x lower in latency. So what it means is that you can increase the bitnets, the size of the bitnet, so that it matches the full precision transformer while still having multiples benefit in memory and latency performance. This is great. So as I mentioned, you can go on to GitHub and find implementation in PyTorch for the BitNet itself. It's written in Python, compatible with PyTorch. So let's use it. All right, so this is going to be the next section, but before we are discussing this, I want to go check my Gemma 7 billion parameter. All right, I think it's confirmed that you cannot use Gemma 7 billion parameter in Colab with CPU on the free version. You will run into insufficient RAM. Conclude. All right, let's get back to our main business here. Okay, this is important because it's just not for the beauty and fun of using AI for your needs. It needs to create values, especially for business. So for managers, CTO, tech team, this is important for you. It's something that you can apply to your business cases, convincing your stakeholder, or starting with what's the best way to think about generative AI project and how to start it. Let's take a look at this success case. So Klarna has implemented customer assistant AI for a month now. But who is Klarna? Klarna is an e-commerce payment solution platform. They serve both merchants and shoppers. They try to give customers the freedom to choose how and when to pay. They offer like direct payments, pay after delivery options, or installment plans. They actually do more than that. This is information from Crunchbase. It's a huge company, global. Now this is their situation. They have 150 million global active users, about 2 million transactions per day. They work with 500,000 global retailers across the globe, and these include well-knowns like H&M, Saks, Sephora, IKEA, Expedia, Nike, and Airbnb. They exist in 23 markets and possibly at least identified 35 languages. What's the objective of their customer assistant AI that I have read from their website is that they want to enhance shopping and payment experience, and this should be multilingual. This could be like customer services, handling refund and return, solving payment issues, handle cancellations, other disputes, some inaccuracy or mistakes in the invoice or ordering system. So these are the objectives that this customer assistant AI should solve for Klarna. Here, after 1 month of deployment, this is their outcome. The AI has carried about 2.3 million conversations in just 1 month. And this is equivalent to hiring 700 full-time agents. This is crazy. If I need to handle 700 full-time agents, I am going to explode. Also, this AI reduce the repeat inquiries by 25%, and is claimed to be due to its accuracy. To think about think about this a little bit. If you are handling lots of human, right? How do you make sure that every one of them give the same answer to a particular issue? So you need to have a very strict procedure, right? But this is no problem to AI at all. You create it once and it will repeatedly, consistently perform, right? This is the accuracy that the AI is better than lots of humans. Resolving time is down from 11 minutes to 2 minutes. That is equivalent to 80% drops. This is insane. Like, we know in the business world, we know Pareto principle, right? This is like doing 20% of the work and that achieve like 80% of the result. This is impressive. In terms of customer satisfaction, Klarna said that it's on par with human. So I think this is, for me, it's very hard to get the evidence of this, but I need to believe that it's doing it's so. And also based on this, I think based on these performances, it's expected that for the whole year, this program, having a customer assistance chatbot program, will make 40 million, or will contribute to 40 million in profit of this year. To me, this is a success case, and I will try to decode their success. So the first thing, I think what they are doing, or what they were doing, and they were doing it right, is to understand objectives and tasks that needs to be done, and what needs for the AI to do. And this is what we mentioned before. They want to enhance shopping and payment experience, and they then broke it down into features or tasks that need to be handled. Like it needs to handle multi-languages, needs to handle return and refund, inquiries about incorrect information of the invoices, disputes, cancellation, payment issue, negotiation. Can I pay in 6 months, each month installment, something like that? So these are tasks that the AI needs to handle. Now, the second challenge, and I think they have done it well, is mapping the flow of tasks and see how the big picture down to the very detail. This chart is not from Klarna. This is what I project that they have thought about this as well. They have to go to see what kind of systems that they are using. Most companies use SAP, ERP, WHM. So ERP, enterprise resource planning. WHM is warehouse management, similar to on the same idea as inventory management, like payment system, order taking system, customer relationship management, or those like customers insights database, and sometimes product database. So companies will probably have a lot of these services. The companies can implement these themselves, but very unlikely. Most likely they will use third-party services. So the challenge is now accessing this, or consolidating this, so that your LLM or your AI can access it. So this is a flow that will need to happen, right? First, the chatbot will receive user's query. It needs to understand what that query is about. Should it be about return and refund? Should it be payment? Should it be asking about the products? So the system needs to classify the task that is involved on that particular chat sessions, and it needs to act for some specific task, like calling information from these databases, or some tools like a calculator if it needs to summarize the order, the invoice of the order, something like that. This is about accessing information that are in different silos appropriately and transforming that retrieved information back to the AI to understand. So this is a difficult task to do, and you need to manage as well. This is a challenge about integration of information. Now, assuming that you have retrieved you have connected to your databases, well, you transform that database returned information. You have transformed it in the language that the LLM, your AI, will understand. The AI needs still need to answer properly based on that provided information. This is about hallucination. This is the correctness of the answer. And then you will likely have to have your final process to craft the final response. You probably don't want to at least for me, what I've seen is that sometimes the AI answer too long, not in a way that the human would do. AI will probably like answer in 5 sentences long. This is what this is not user friendly. So we probably need some way to craft your final message in a way that is user friendly. So yeah, these are the challenges that I can foresee that Klarna has done really well, or at least it turned out to be well executed somehow. Now, the third one is defining metrics and measures. You're not going to know if you are successful at all until you know what you want to achieve, the metrics, and what has been done in the past. Like, okay, if the adoption is so, according I forgot to mention the 2.3 million conversation is about 2/3 of the conversations in that period of the AI. I'm sorry, try it again. 2.3 million conversation that Klarna has seen the AI handled. It is about 2/3 of the overall conversations, AI and human included. So it's 2/3. It's huge adoption. So one of the metrics that Klarna might have aimed for is adoption. This is a good metric to evaluate the effectiveness of the AI system, the accuracy, right? And the accuracy is now, it has a proxy, it is proxy towards repeat inquiries. The effectiveness can be measured in the time needed to resolve a problem. So this is a good metric as well. Another one is customer satisfaction. I think this one is done via asking customers to give a feedback on his or her experience with the chatbot today. Klarna could have skipped it, but I don't think it should have. It is doing right. Sorry, Klarna is right at implementing this because customer satisfaction at the end of the day is important to the business. There might be other metrics and measures that Klarna have done but not mentioned in their website. I can think of a few things like unsuccessful conversations, what happened, really bad customer satisfactions, how many of them, and the reduction of possibly returns and refunds. Like if the customer comes in and he or she wants to return the product, what's the percentage of customers that change their mind? They now want to keep the product. That could be another important use case for the chatbot as well. Right. So now an audience have actually asked me about challenges in adopting generative AI in business. I can answer that from my current working experience and could be related to this business case that we went through. So I wanted to divide the challenges into two categories. The first one is technical challenges, and the second one is non-technical challenges. And I will identify the big ones that I think is important to be aware of and tackle it head on when you are about to start your generative AI or thinking about starting it. The technical challenges of companies that I have seen is integration with other systems. As I mentioned, a company might have been using third parties to manage resources or executing some operations. Those will include SAP, ERP, WHM, payment system, ordering system, CRM, and products, and so on. It could be many other things. Integration these together, especially for the need for accessing this information so that the large language model can have the information to answer the customer. Integrating this and handling it well is important and oftentimes very difficult. You'll find fragmentations of your information, sometimes even outdated information, or worse, not existing at all. Actually, not worse. It could be the non-existing system might be easier to handle, but still, you need to handle non-existing systems. The communications in this, I mean, executing API calls and transform the calls feedback so that the LLM understands. For example, large language models are really good at unstructured human language, like reading novels, writing blog posts, but they are not so good at understanding structured data like tables, graphs. So how do you do that? It's very important as well. Think about it as a receipt. If you have a picture of, let's say, a receipt or invoice, human can understand that, but the invoice or receipt are typically semi-structured data, right? You have names there. You have names of the product, price, quantity, and the total price before tax. So this is a semi-structured data, and this is not so easy for the large language model to understand. So how are you going to prepare or transform the information in invoice format to something that the LLM will understand? Or you need to adopt a custom trained LLM model that is better at understanding table. So there are choices there that you have to make. The second topic is about the model itself and the data. Let's talk about data first. So data management is crucial here. If you don't have data, how do you acquire it? And if you have data, when you have data, and you wanted to provide to the large language model, what kind of processing you need? If you are fine-tuning the model yourself, you need to do a lot of data cleanup and data pre-processing. Who is going to do it? What kind of procedures or processing workflow that you need to do? And when we talk about data, now it also touches regulations for like privacy issues, and do you need to think about it really well? The model is it's difficult in the sense that first you need to select the model, and then you might need to fine-tune it. Selecting the model could be easy, but if you don't do it right, it's going to cap on the performance of your model. For example, if you want to provide a multilingual services, but you select the model that is only trained on English, this is not going to be a good way to go. Now, in terms of modeling, if you only use publicly available dataset to train your model or fine-tune your model, what it's going to do is that you will get a model that is good in generic purposes, but might not be specifically tailored to your applications. For example, if you're working at a law firm and you want to serve clients, like a chatbot that can answer something about legal issue and legal processes, but you only use ChatGPT, similar style of training, like training on the general public data, your AI, your chatbot is not going to do well, because he or she, well, not he or she, the AI doesn't know specific terms in the legal world. And another thing is, if you only use publicly available dataset and open source model, you are not going to have any key advantages in your AI. Anyone with enough resources can take the same publicly available dataset, take the same open source model, and tune it. And if you don't have, let's say, like an top tier AI talent or expert in your team to fine tune the model, it's very unlikely that you will gain any key advantages in the AI model that you just created at all. So what you need is proprietary dataset in order to fine tune the model to your specific application. But it now involves high quality data that you need to aggregate, pre-processing, and then fine-tuning the model. So these are the challenges that is related to modeling and data. The third one is security and privacy. In a technical sense, it means how do you make sure that your AI model doesn't provide something harmful, unethical, and false, right? You don't want the model to hallucinate. Let's say, it's a legal matter and the model actually hallucinate that the client can win, or the client is, you can just bypass this process. So this is not right? You need to be able to handle incorrect prediction, biases in your model. This is a technical challenge. The last one is, especially in production or actually providing AI services to the actual world, you need to implement these process: deploy, monitor, and improve. This is what they call machine learning operation, or MLOps. It should be adapted to or applied to this generative AI project as well. All right. Now, the second category is non-technical challenges. This usually comes first and is equally important. But for projects that are starting, I recommend you focus on these non-technical challenges first. The first one is identifying goals and roadmaps for implementing or experimenting. You need to do this first. As Steve Covey would say, climb the right ladder, right? Yeah, climb the right wall. You need to pick the right wall to climb. Goal and roadmaps are important. You need to ask yourself, why are we doing this? What is it applied to our core business? Backward a little bit. What are your core business operations? Do you know it? Do they have problems there? If that problem of your core business, can AI solve it? And if you are experimenting, is this going to disrupt your business as usual? If it does, what percentage should you allocate to experimenting? 10%, 5%? This is your call. But again, you need to be clear on the goals and the roadmaps of this project if it plans out. You will also need to handle uncertainty, right? Most of the time, my managers or my up levels will ask me estimate the return of investment on AI projects. It's very difficult. Most of the projects that I've done, it's very advanced compared to the company's status. Because I'm in the R&D team, I'm supposed to be doing something that would not return profit in 2 years. Maybe this is not the way of looking at it, but this is where this is what I think it should be doing. So advanced research can be difficult to define the role, the return of interest. But I usually do my best to compare the current operation cost to the AI operation cost, and then benefits and benefits. So trying to do the cash flow projection, and then you will see a better picture. But again, this AI procedure can be uncertain in a sense that the outcome might be unpredictable. Sometimes it works, sometimes it doesn't, sometimes it works, but even simpler solution will work too. So you need to be able to handle that. At least you need to identify what can go wrong, what is an non-AI alternatives that can do the job as well. Change management. Because AI projects most of the time are not isolated. It needs to serve other businesses or other groups as well. And this is difficult. People don't like change, and people might have conflict of interest, like KPIs, for example. Now, how do you convince other teams to give you a hand or collaborate or cooperate so that your AI initiatives or AI projects experiment can go forward and show some meaningful results? You need to do that too. Other people can also fear that, okay, I might be replaced by AI. You need to explain that this is not going to happen. How this is not going to happen? How are you going to enhance their capability so that they can remain at their job but doing their job better? Stakeholder management. As I mentioned, there will be multiple stakeholders, and you need to get buy-in and commitments. So you need to know who has the authority in the team that you want to work with, so that you can get the buy-in from him or her. They should have authority. They should have a say, right? If you go to like the team member who doesn't have power to decide, it's going to be useless. You need to find someone who actually has a say and get a buy-in from him. The last one is how are you going to access technical talents? You need to decide if you are going to hire somebody to be in-house or can you outsource it. So this actually depends. There are pros and cons in these two choices, and I think you know it. In-house can be difficult to find, expensive. Could be relatively cheaper than outsourcing, but there are other things that you need to be able to keep him, providing resources, tools that you might not even have. Like if your company don't use cloud computing platforms that are AI enabled, maybe you need to buy that tools too. Are you willing to invest in that? But if you compare it to outsourcing is easier. You don't need to hire someone. You don't need to handle HR process, but it's going to be more expensive, and you are not sure if the outsourcer can fulfill your needs. Okay, there you have it. Technical challenges and non-technical challenges, and I think when I went through this list with you, I have provided some answers or suggestions to handle these two categories. Yep, that brings us to a close. So to summarize, in this live episode, you have seen Gemma, the Google's open source model that comes in two sizes, 2 billion parameter and 7 billion parameters. Both of them have a pre-trained and instruction fine-tuned version. It's available on Hugging Face, and have shown that you can use the 2 billion parameter instruction tune modeled on Colab for free using GPU. You should get your hands on that as well. I also have failed significantly at loading the 7 billion parameter to Colab. Well, I'm using it free, right? I don't have enough RAM to hold the model. Mistral Large, it's now performing the second in the closed source LLM. To me, Mistral is trying to make money, but at least it provides you an alternative, a good performing alternative in the closed source large language model world. You don't need to be relied solely on OpenAI alone anymore. Next one is the BitNet. It's a new implementation of the large language model that saves a lot of memory and saves a lot of energy consumption. Therefore, it's faster to compute, and it has huge potential to be implemented or to be deployed on edge devices like mobile phones or the IoT computers. And the last one, we talked about a success business case of using AI for business. We were talking about AI assistant that Klarna, an e-commerce platform, has deployed. And only 1 month it has seen a lot of success, like 2.3 million conversations, accounted for 2/3 of its conversations, and that is equivalent to 700 full-time agents. Save a lot of headaches for sure. The response time has dropped 80% from 11 minutes to 2 minutes. So this is a good success case, and we dived into decoding its successes. I have identified 3 steps. If you don't know what it is, go back and take a look at the video again. And we close it with my, based on my experience and in relation, in seeing Klarna's success. Based on that, I talked about challenges in adopting generative AI in general, and so that you know, if you want to do generative AI or you want to start your journey in generative AI, what you will see. All right, that brings us to a close on this live episode. So don't forget to subscribe to our YouTube channel and other social media channels as well. As you can see down here, we have a website, www.cashedon.ai. We also have Facebook and LinkedIn and YouTube channel. So please subscribe here. If you think this is useful, you all can also share it to your friends, your team members, your managers who are looking for ways to improve their businesses with AI technologies. Please share with them. And also, if you have a comment or a questions after seeing this video, you can leave it in the comment section, and our team, me, will come in and give you the answer or provide you with our opinions as well. So in the future, I'm thinking that I will be talking about LangChain, possibly Llama Index, and the thing called RAG, which stands for Retrieval Augmented Generation. It seems to be a hot topic right now. Everyone is chasing after this. Even my company, I'm implementing RAG project for my company as well. So in the future, I think I will provide you with some basic understanding. We can go through code, we can go through LangChain libraries and see how useful or how you can use it yourself. So lastly, I'm very excited to say this. So I'm on my way to construct a course that will actually provide you with a solid foundation of large language model and tools needed to build the application yourself. I hope that it's going to be an end-to-end application that you can actually you can do it yourself, or your team can now, after taking the course, will be able to do it. All right, this is the end for sure. But again, don't forget to subscribe below. Have a good day.